Okay, today we're continuing with talking about algebraic relationships, specifically additive relationships is what we're going to focus on today. You need to be on page 467, and this is chapter 6, lesson 5. And if you'll notice up here in the title, y is equal to x plus a. And you can see this is different than some of the equations we've been writing involve the variable x being multiplied by something, and you can see this is actually has an addition operation symbol, and then the letter A. Letter A is going to represent the constant, and we've seen constants in equations before. These are numbers that do not have variables attached to them. So let's go ahead and look at this word problem. We're going to see what additive relationships look like. Manuel has a $20 gift card to an electronics store and some money in his savings account. He can buy an item that is $20 more than the amount in his savings account. Make a table that represents the amount in his savings account and the amount he can spend. Okay, so the first thing we're going to do is we're going to complete the table. So we have, if he had $50 in his savings account, he also has his gift card. So how much total money could he spend? Go ahead and answer that for me, please. Okay, the correct answer is 70 because he has got $50 in the bank. But remember, he also has that gift card. So 20 plus 50 is 70. That means that if he has $60 in his bank account, he could spend $80. If he had $70, he could spend $90. And if he had $80 in the bank, he could spend $100. So that's the table completed. Now we're going to graph the ordered pairs and down here. So the amount in his savings account and the amount that he could totally spend, the amount in his savings account, that is going to be the independent variable because depending on how much he has in his savings account, he can spend more money by $20. So that's going to change the amount that he can spend. So the x-axis is going to be the amount in his savings account. Now, if I go ahead and make my little parentheses here, the x value is 50. The total amount he can spend is 70. And these are going to be the ordered pairs. So I'm going to go ahead and graph this. So if I go over 50, that's in between the 40 and the 60. I'm going to come up to 70, which is in between the 80 and the 60. So I'm going to put my first point here. And then I come over to 60. I can go up to 80. And I'm going to go to 70, which is in between the 60 and the 80. I'm going to go up to 90 in between the 80 and 100. And then if I have $80 in my bank account and I add $20 to that, then I'll end up with $100. Okay. Now, so this is how we graph those ordered pairs. Describe the graph. Okay, now, I'm going to go ahead and I'm going to continue the graph and I'm going to connect the dots. So I'm going to pause to do this. We can tell it's a linear graph, but here's an important piece of information. If, for some reason, we had no money in the bank, so I'm going to come up here to my table. I've got no money in the bank. I still have that $20 gift card. So I could still spend $20. And you'll notice on the graph, if I had zero money in the bank, I could still spend $20. This is different than some of the other graphs we've noticed always went through the 0, 0 through the origin. This does not. So this additive relationship does not go through 0, 0. That's another important thing to make note of. So it is linear, but it does not go through 0, 0. It does not go through the origin. That's something else that's really important for us to know. So write an equation to find out how much you can spend with X dollars in savings. So that's the dependent variable. So if we have the dependent variable is the total amount we can spend, the total amount we can spend is equal to the amount in savings. So let's just call that S. So whatever we have in savings plus $20. This is going to be the equation that we write. And so what operation is represented in this relationship? Go ahead and answer that for me. Okay, clearly it's addition. All right, so determine additive relationships. Additive relationships compare the independent and dependent quantities of relationship using addition. Additive relationships can be represented as tables, graphs, and equations in the form of y is equal to x plus a, the constant, where a is any rational number. All right, so on example 1, we're going to determine whether this is additive or if it's not additive. And we're going to learn tomorrow when it's not additive, it's called multiplicative, and it involves multiplication. And we've already seen some of those in previous lessons. All right, so if you look at the input, the independent variable x, if you have 4, all of a sudden it becomes 8. So when you have 4 and it becomes 8, it could be multiply by 2, or it could be add to get add 4. So we always look at the next relationship. So if you have 5 and you have 9, is 2 times 5 going to equal 9? Answer that question, yes or no. No, and 6 times 2 doesn't equal 10 either, but 5 plus 4 equals 9, and 6 plus 4 equals 10. So in this case, up here, the rule is plus 4. So if you have 4 plus 4 is 8, 5 plus 4 is 9. So y, the value of y depends on the letter x, whatever the letter x is, plus the number 4 would be the equation. And so this is definitely additive and not multiplicative. Okay, so for number 2, it says each amount is 3 times the input. Okay, so if we look up here, 3 times 3 is 9, and 5 times 3 is 15, and 7 times 3 is 21. So in this case, it is not additive because you are multiplying. So this particular rule would be y is equal to the number 3 times whatever x is. So this we're going to learn tomorrow is called multiplicative. So it is not an additive relationship. It involves multiplication. And finally, looking at this graph down here, it says each, if we look down here, well, before we look at over there, it says, this is the first point right here. So the first point is 1. So if x is 1, y is 4. Okay, so I'm like kind of making a table here. And then we have another point. If x is 2, then y is 8. Well, what do I do to the number 1 that's going to make it a 4? So the options are add 3 or multiply. And I need to stop using the x. It's kind of hard to stop. Or multiply times 4. Okay, so 1 times 4 is 4, yes. Is 2 times 4 going to be 8? Yes. 1 plus 3 is 4. Is 2 plus 3 going to equal 8? No, so this is not an additive relationship. The other clue is it goes through the origin. And multiplicative relationships go through the origin. Additive relationships never go through the origin. So that's the other clue. This is not an additive relationship. Okay, so multiple representations of additive relationships. So basically, the equation will be based on y is equal to x plus some constant number, any rational number. We can create tables showing this, and we create graphs showing this. So the verbal description says Isaiah has 28 more songs downloaded on his MP3 player than Melanie. And so on the graph over here, number of songs Melanie's downloaded. If she downloaded 10, he did 18 or 28 more. So 10 plus 28 is 38. She did 20, he did 48. So this is showing the rule that everything that she did, he is always going to have 28 more. So this is showing this in the table. Now, when we graph it, you'll notice down here 10, and you're going to go up to 38, which is right below the 40. Then if we look at 20, it's 48 right below the 50. If we look at 30, it's 58 right below the 60. So this is how this table is represented as a graph. So these are representing the same data. So we graphed all of those points, and this is what that looks like. Now, if I were to connect this, you can see it has a linear relationship, but does it go through the origin? No, it does not go through the origin. It actually crosses the y-axis at what number? 28. And it crosses at the number 28 because, let's look at our equation down here. So the number of songs that Isaiah has is going to be equal to x plus 28. So what is independent is Melanie. So whatever Melanie has, he has 28 more. So that's why this constant is where it crosses the y-axis, because if she had 0 songs, he would still have 28. And that's why we don't have 0, 0, and that's supposed to be curved. Sorry about that. That's why we don't have 0, 0. We have 0, 28, because even if she had nothing, he would have 28. Okay, so hopefully you've picked up something important that you need to remember. And if you haven't, please go back and look through what is important to remember about this lesson. And go ahead and answer that for me. What is the most important thing, or what is something you have learned in this lesson that you need to remember? Go ahead and answer that for me now, please. Thank you for your thoughtful answer. Please come to Math Live so we can do some more examples together. I will see you later. Take care.